ANOVA without replication, and or two-factor ANOVA with Kij equal to 1. ANOVA stands for analysis of variance, so naturally you're running the analysis of the values you can see there on the chart, represented by X and numbers of each individual data point. Numbers are factored into a factor A and a factor B. As seen in the graph, factor A is along the x-axis and factor B along the y-axis. Factor A is the level I, and factor B would be the level J, and Kij equal to 1. You may be wondering why Kij equals 1. What that means is simply that the data was collected on one observation and one observation alone of a particular test or experiment or whatever. Here's a visual. You can see how this is only one observation because K would be a third axis. Slide 2. On this slide, you will see various formulas to find values needed and significant to our testing or experiment or whatever we're doing. There are two unknown variables, and so you see there SSA is the sum of squares of A, SSB sum of squares of B, SSE sum squares of the area, DF is your degree of freedom, MSA is the mean of the squares, and F is your just F factor. Those are the equations you use, sum of squares, F ratio, and you can use the fixed effects method or the additive models method. They're both useful. These are when you evaluate your hypotheses. You need a null hypothesis and a alternative hypothesis. You need to reject or accept the null. The null is usually something like, A1 equals A2 equals A3 equals 0. The alternative would be that at least two of those are not equal. Application engineers, testing soil, anything where multiple factors are involved. So the effect of a treatment on a strength yield of a material, because you have a different material and you have a different treatment. And here are my sources.